It's floating.
Why is this so important? Sorry. That sound doesn't really do much for me, but what's making that sound is ice. And in this video, I want to talk about ice, and then I want to talk about what happens to solid water when it gets warm. By the way, I've hidden this picture of a goat somewhere in the video. See if you can find it. So what's so special and important about ice? Helps to keep my drink nice and cold. I agree that a cold drink is something special, but I wouldn't argue that it's all that important. Come closer. It's floating. And believe it or not, that's actually extremely weird. It doesn't seem weird because we're used to floating ice, but most things don't float whenever they freeze. Whether something floats or sinks is really all about how dense it is. And density comes down to how tightly packed all of the particles are inside of something. For most materials, this changes in a pretty straightforward way when you go from a solid, where all the particles are really tightly packed together, to a liquid, where the particles are a little bit more loosey-goosey, and then eventually to a gas, which is the most loosey-goosey of all. But water took one look at this whole thing and went, not for me. I don't like the way that goes. I'm gonna flip this whole density thing when it comes to solids and liquids. And to understand how it accomplishes that, we need to get to know our good friend, the water molecule. Hello. Oh, I liked it a lot better without a face. So the water molecule has 2 hydrogen atoms and 1 oxygen atom, which is where its cute nickname H2O comes from. And the oxygen atoms are like really into the hydrogen atoms, like to the point that they're even attracted to the hydrogen atoms in other water molecules. This phenomenon is known as hydrogen bonding. Now, water is not the only molecule that experiences hydrogen bonding, but it is the smallest. The hydrogen bonding makes the water molecules a pretty tight-knit crowd that doesn't like to get separated, and this makes it a pretty dense liquid overall. But things start to get really weird when it gets cold, like really cold, like freezing cold. Under normal atmospheric conditions, water freezes at 0 degrees Celsius. Or, you know what? Screw it. If you live in a place where the units don't have to mean anything, let's just spin the wheel and come up with 32 degrees. When the water molecules start to slow down, that hydrogen bonding makes something really special start to happen. The oxygen atoms start getting to act like they're holding hands with more hydrogen atoms than they really are, and they start to naturally arrange themselves into this 6-sided shape. And since this hexagonal region is empty in the middle, this means that the molecules actually take up more room in their solid state than they did as a liquid. And that is how ice ends up being less dense than liquid water, and why ice floats. You can see this for yourself by taking a cup of water, indicating how much is in there, and then setting the cup to freeze. Once frozen, you'll notice that the level comes up higher than it did. Oh my god. Once frozen, you'll notice that the level comes up higher than it did as a liquid. But what if you were to do this with a liquid that isn't water? I tried this with canola oil because it's the only household liquid I had readily available that isn't mostly water. And for one thing, I wasn't expecting it to turn white when frozen. I don't know what I was expecting, but it wasn't that. For another thing, and this is a little bit hard to see in the video, rather than expanding like water did, the oil actually shrunk a little bit. This means that frozen oil will sink in liquid oil instead of floating like ice does. And yeah, that was frozen oil and not a hard-boiled egg. And now what would happen if water did the same thing? Would it be a big deal? Yeah, I'm certainly no expert on the subject, but I kind of think that if ice were to sink instead of floating, you and I wouldn't exist. See, if ice sank, the end result would be that things like oceans and lakes and other bodies of water would essentially freeze from the bottom up. And if that were to happen, it would basically allow these bodies of water to freeze solid in really cold temperatures. Marine life as we know it would not be able to survive winter. And when you think about it, since life on Earth is believed to have all started in the oceans, ice is kind of our origin story. But it doesn't have to stop being interesting just because it stops being ice. So here are 3 fun facts about water told to you from 3 weird places. Water holds the world record for being able to dissolve stuff. That doesn't mean that just anything will dissolve in water, but it does mean that more things dissolve in water than in any other substance. Water is extremely stubborn about having its temperature changed, meaning it takes a lot of energy to warm it up, and when it does warm up, it takes a long time for it to cool down compared to other substances. In fact, Water is more stubborn about temperature changes than pretty much any other substance you're likely to encounter in daily life. Water is one of the only naturally occurring substances that can be found in all three states of matter on Earth. Cold weather brings us solid ice and snow. You've likely already seen liquid water out in the wild. And then there's water vapor. I bet you thought you were about to see clouds. See, there's a problem with that. Water vapor is actually very shy. It doesn't like to be seen. So pure water vapor is completely colorless. And when you see things like clouds and steam and, your breath on a really cold day, which I can't see right now. I don't know why. I can kind of see it, but I don't think the camera's picking up on it. What you're really seeing in those cases is where water vapor has actually started to condense back into little droplets. Whoa, I just stepped in a really deep spot there. Yeah, my feet are gonna be wet. Steam, clouds, breath, things like that you can see, not water vapor. If there was no invisible water just floating around in the air, then this guy would be out of a job. But here I am, emptying the tank. That's all I had for this video. Thanks for watching.